Hi, good morning, my dear students. I'm Daphne Cole. Welcome to my discussions. Today, we will discuss about the topic of reactions kinetic. In this topic, we need to know how to determine the order of the reactions. There are two methods to determine the order of reactions in STPM syllabus. We can use the method of initial rate or the graphical methods. However, in our discussions today, we will use the method of initial rate to determine the order of the reactions. Now, let's go to the first part, the method of initial rates.
My dear students, from this video, we want to discuss how to determine the order of reactions by using initial rate method. However, if you want to know how to determine the order of reactions by using the graphical method, you may refer to the video in my YouTube channel. At first, we need to write down the general form of the rate equations from the reactions. In the rate law, the exponents are referred to the reactions order. Let's say if reactant A has an exponent of 1, then the reactions is first order with respect to A. Always bear in mind that a rate equations cannot be predicted from a balanced chemical equations, but is determined experimentally. In the syllabus, there are two methods to determine the order of reactions, either the initial rate method or graphical method. In this method, several experiments are carried out using different initial concentrations. Then, the initial rate is determined for each of the initial concentrations. To determine the order of reactions, we compare the data from any set of two experiments, write the rate law, and divide them to see how the rate change. Then, set up a ratio of concentrations and rate to fix the rate law equations. Therefore, you can use these equations to determine the order of reactions. Now, let's look at the questions. We are given a table of data that relates initial concentrations of reactants with initial rates of reactions. Then, ask us to determine the order of reactions with respect to X and Y2. At first, write the general form of the rate equations from the chemical equations given by the questions, where K is the rate constant, while A and B are the order of the reactions. To determine the order of reactions with respect to S, which is A, we need to use these equations. So, what we need to do here is we need to choose a pair of experiments where only one of the initial concentrations of the reactant changes, but the initial concentrations of another reactant is constant. Therefore, I need to choose the experiment where the concentrations of S changes, but the concentrations of Y2 remain the same, so that any changes in the initial rate, of course, it is obviously because of X. So, we compare experiment 1 and 2 to determine the value of A. Next, substitute the value of initial concentrations of X and initial rate into the following equations. Then, simplify the equation into this form. Finally, we can get the value of A is equal to 2. Or we can say that the order of reactions respect to S is second order. By using the same approach, the order of reactions with respect to Y2 or the value of B can be obtained by comparing experiment 1 and 3, where the concentrations of X is constant. Then, by using the following equations and the data from experiment 1 and 3, substitute the value of initial concentrations of Y2 and the initial rate from experiment 1 and 3. Lastly, you will get the value of B is equal to 1, or we can say that the order of reactions respect to Y2 is first order. Therefore, the reactions is second order with respect to x and first order with respect to y2. To determine the rate equations for these reactions, we need to substitute A is equal to 2 and B is equal to 1 into the general rate equations. Therefore, the rate equations can be written as the following.